Hey guys, and welcome back to another video on the channel. In today's video we're going to be doing the Math Methods 2020 paper 1 tech-free short responses in this video. This video is going to be broken up into two parts because this is a 90-minute exam, and since I'll be explaining it, it'll take longer than usual to go through each question rather than just writing it down because I'll be explaining it. So what might take pretty much 5 minutes in the exam was probably going to take 15 minutes in the video because I'll be explaining it step by step rather than just writing it down pretty much. But anyway, let's get straight into it. So straight off the back, it's tech free, so all these are done without a calculator. And yeah, this is the Math Methods for Queensland under QCAA. Let's go straight to question 1. Here we go. Oh, not question 1, question 11. So question 1 to 10 was multiple choice, which we have covered on another video on the channel, but today's video is just the short responses now. So determine the derivative of the following with respect to x. So that's pretty much this and this here. Okay, so it's total is 3 marks over 2 questions here. So here, let's just rearrange this so it's much easier to do. So you can use the quotient rule, the chain rule. Personally, I'm going to use the chain rule because you can rewrite this function like this. You can have sine x to the power of -1. And then straight away we can differentiate that using the chain rule. Now you don't need to write it down. I know in some marking guides you do need to write it down, but if you just do it using the chain rule, they'll see and they'll give you the mark. They're not going to not give you the mark because you differentiated it correctly but didn't write the chain rule. They'll just be silly of them. So all you got to do is just rewrite dy dx, and here the chain rule. So we differentiate our outside function, so we need to identify what's our outside. So our outside function is pretty much this bit here, this -1. So we just use the power rule and bring the -1 down the front, rewrite our inside function again, and then subtract the power by 1. So this will be -2. Now the second part, we need to multiply by the differential of sine x, which is cos x. So that would be your first line of working. And just to rearrange this, we'd have dy dx is equal to -1 times cos will be negative cos all over sine x squared, because this is a negative exponent, so we can move it under a fraction and then rewrite it like this. The reason I wrote it like that is because sine of x squared is the same as this. It's just a notation for it. So this here is the correct answer. Okay, and that's all you pretty much need to do. Alright, let's go down to B now. So B, differentiate this, but express your answer in factorized form. So straight off the back, we have a function next to a function. So we're not really thinking chain rule, we're thinking more product rule, because product means multiplication, and we can see a function times a function. So there's no easier way to write it. We can just leave it like that. So we have dy dx. So the product rule means you differentiate the first one. So we'll write it like this. Differentiate the first one, leave the second, plus leave the first, and then differentiate the second. So if you don't know what I've just written there, this symbol means the differential operator. So if I write that, that means I'm going to differentiate that, but I haven't done it just yet. So that would be the setup point for all that. So now we just differentiate the terms here and see what we get. So dy dx. Differentiating x squared, you bring the 2 down the front and subtract the power by 1, so you can have 2x, and then times by this. So e to the -x plus x squared stays the same. Differentiating this, now if you differentiate e to the x, it stays the same. However, if you differentiate e to the x and it has some number up here, you need to apply the chain rule. So you bring the whatever this is down the front, so you have a e to the ax. Here we have -1, so this is going to be negative. Now this is multiplication, negative e to the -x. Okay, and that would be that differentiated. If you're not sure on that one, just leave something in the comments and I'll probably explain that a bit better if you want that more detail, but that's pretty much the gist of it. So we can rewrite it like this. Dy dx is 2x e to the -x plus x, minus, because it's multiplication, so minus x squared e to -x. Now, notice we're not done yet because they want it in factorized form, so you look for what's common in both terms here. So straight off the back, I can see the Euler term is common, so I can rewrite that out the front, but I can also see an x is common in both of them, so I can also write that. So if I factorize this stuff out, what I'm going to have on the inside is just 2 minus x, and that's it. This would be your final answer. That is correct, but they're specifically looking for factorized form, so this would be the overall correct answer in the marking guide for this test. Okay. If you have any questions about that, just leave something in the comments and I'll try my best to answer it. Alright, let's go down to question 12. An object is moving in a straight line from a fixed point. The object is at the origin initially, and the acceleration of the object is given by the following function. A of t is pi cos of pi t, where t is greater than 0, where t is time in seconds. The velocity at t equals 1 is 0.5 meters per second. Determine the initial acceleration and the initial velocity. Okay, so let's unpack this. So what we have is a function of acceleration. So this all comes back pretty much to a physics idea. So position we know is a function of time. If you differentiate position with respect to time, you get velocity. Oh, that's not a v. You get velocity, v of t. If you differentiate that with respect to time, you get acceleration. So if we're looking for pretty much anything to do with velocity, we need to do the opposite of differentiation and go backwards. Now, we don't need to do it in this question here, but we might need to do it here, because we're looking for an equation of velocity because we're looking for an initial velocity. Now, if you see the word initial means t equals 0. So straight off the back, let's just highlight where initial appears in this question straight away. So initial appears here, here, here. So all that means t equals 0. Now when they say origin, that also means x equals 0. So your position is 0. This means t equals 0, and this means t equals 0. Okay? So you're looking at the acceleration when t equals 0. So for this first question, you go a of t is pi cos of pi t. Substitute t equals 0. You get pi cos of pi times 0, which is still 0, so you get cos of 0. Cos of 0 is 1, so the answer is pi. Now you can leave it like that, or you can include the units, meters per second squared. Okay. Since it's only worth 1 mark, I don't think you'll get pinned if you don't have units. So as long as you put pi, I think you should be all good, but who knows. Okay. So determine the initial velocity. So what we have here is acceleration. So if we want to find velocity, we need to integrate with respect to time. So v of t is going to be the integral of all this with respect to time. Now, it has to be with respect to time. It can't be with respect to anything else. Otherwise, that won't give you velocity. Pi dt. So, when integrating this, divide by the differential of our inside function. So, the differential of pi t would be pi. So, that pi would cancel out. And if you integrate cos, it turns into sine. So, the answer should be sine of pi t plus c. So, now how do we work out what this plus c is? Well, we got told this information up here. The velocity at t equals 1 is a half. So that means, yep, t equals 1, v equals a half. So, if I sub that in there, we get v of 1, sine of pi times 1 plus c is a half. Sine of pi is 0, so that means c is a half. So our equation here, I might rub it out now because we're going to need some room. If you want to look at that a bit more, just rewind the video. V of t is sine of pi t plus a half. Okay, so I'm going to rub all this out. So we just have enough room for the last bit, okay? Now, obviously you would include all this working I'm rubbing out. I just don't have enough room because the pen's a bit too big. And unfortunately, I can't write as small as I would do if it was on paper. Initial velocity, t equals 0. We just sub that into our equation now. So you go, alright, t equals 0. V of 0 is sine of pi times 0 plus a half. So v of 0 is a half meters per second, and that is the initial velocity, okay? Or that's what you should get pretty much. Okay, if you get anything else, you've probably made an error somewhere. Just the best thing to do with questions like this is to take it nice and slow. So I identified the pattern where to go from position to acceleration, you need to differentiate with time. And to get from acceleration backwards, you need to start integrating. So making that assumption and stuff straight away helps it so much. And then identifying the initial parts helps it so much, because the rest of this information is going to help out with part C. Determine the displacement after 1 second. So that means we're looking for a function of position with respect to time. So in other words, we're looking for x of 1. So this is what we've got at the moment. Velocity of time is sine of pi t plus a half. Okay. If you want to go to position and you have velocity, you need to integrate with respect to time. So x of t, integrate that with respect to time. So when you say with respect, it's pretty much the variable you attach with the d something. So this means with respect to time. Okay. Now we integrate this, divide by its differential of our sine. So the differential of pi t will be pi. Sine turns into negative cos, so you're going to have negative cos of pi t on pi plus a half integrated with time is just t on 2 plus c. Now we can't answer the question yet because we've got this plus c here. Now we can get rid of that because we got given this information up here. When x is 0, t equals 0, because the object is at the origin initially, and the origin is 0, 0 in this case here. So x is 0 when t equals 0. So x of 0 equals negative cos, and then you replace wherever t is with 0. Plus 0 on 2 plus c, and then we have 0. This whole thing's going to be 0. Cos of 0 is 1, so you're going to have negative 1 on pi, because the negative sign is here. This bit's 1, but times by negative 1 is negative 1, plus c. So that means c is 1 on pi. Okay, now I'm going to rub a lot of this stuff out now, because I don't think I'll have enough room for this last bit. Or maybe, I'll see. Alright, so now we're looking for x of 1. So actually, let's just write our full equation now. So we know x of t is negative cos pi of t on pi plus t on 2 plus 1 on pi. So if I look for, what did we look for? The displacement after 1 second, so that means x of 1 equals negative cos, and wherever there's a t, just chuck in a 1 pretty much. Pi plus 1, 2 plus 1 on pi. So what we're going to get is cos of pi is going to be negative 1 times by negative 1 is 1, so we have 1 on pi plus 1 on pi plus a half. So therefore we can add these together because they have common denominators. We have 2 on pi plus a half is the position at x of 1. Now I'd leave it like that because you can't simplify that any further, because remember, this is a non-calculator exam. Okay. Hopefully that all made sense to you guys. If you have any questions, leave some in the comments and I'll try my best to answer them, alright? Right, let's move on to the next question. Okay, so this question here, a function is defined by f of x is x times natural log all squared. X has to be greater than 0. The graph of the function is shown and has a local maximum at the point A and a global minimum at the point B. The derivative of the function is given by this. Okay. Verify there is a stationary point at x equals 1. So a stationary point is when the derivative is 0. So normally you would just differentiate that and then set it equal to 0 to find a stationary point. But we've been given the derivative here. So all we need to do is pretty much, alright, if I plug in x equals 1 into that equation there, it should give you 0. Because that's the word verify. You're not solving for anything, you're verifying this is pretty much correct. So if stationary points, I'll just write SP, that means x equals 1 that means f dash of 1 should be 0. You write that, then you literally just write the equation. F dash of x is 2 log of x plus log of x all squared. And then you substitute x equals 1. So you have 2 log of 1 plus log of 1 all squared. Log of 1 is 0, so that's 0 and that's 0, so that means f dash of 1 is 0. Therefore, stationary point. You can write it as st, or you can literally write the whole word. That's just shorthand, okay? Because stationary point. Righto, let's move on to the next part. Determine the coordinates of A. Yep, so we haven't actually been given this coordinate here, and we can see it's quite a yucky number at the start. However, we can see it is a stationary point. So since the point A is a stationary point, that means f dash of x will be 0 there. So with our equation here, we know f dash of x is 2 log of x plus, oh, that's a bit wonky, plus natural log of x all squared. We need to pretty much solve this for x when we set this side to 0 pretty much. So if we do that, we're going to get 0 equals 2 log of x plus log of x all squared. Now we're expecting two answers because we can see there's two stationary points. There's one here and one here. We're just looking for A. So if we get a solution that x equals 1, we know that's the point B. We're looking for some number here that's quite smaller than 1. So what do we do pretty much? Well, the first thing we would do is I'd move this term over to the other side. So you have negative 2 natural log of x is equal to natural log of x all squared. And then I'd divide by natural log of x. So if I did that, the reason why that's good is because that gives me this. Negative 2 is equal to natural log of x, and it also gives me natural log of x is equal to 0. So that means the first solution is when x is equal to e to the 0, which is 1, and that's the point B, which we discovered here. And this gives me the second solution. X is equal to e to the negative 2, and that is the x value here. So that would be e to the negative 2 is 1 on e squared. So it's not a negative number, it's just a very small number. So 1 on e squared, which is very tiny. So we have run out of room. I have to rub it out, sorry. So now that we found the x value for the stationary point at the x value at the point A, we need to find the y coordinate, because notice in the question it says determine the coordinates. I don't know why I have coordinates. It should just be coordinate of A because there's only one. The coordinate of A, that means an x and a y. We've got ourselves an x value here, but we need a y value. But remember, we can work it out because we got given our function earlier. We got given f of x is equal to x natural log all squared. So if I substitute this into that, it will give me my corresponding y value. So f of e to the negative 2 is e to the negative 2 natural log of e to the negative 2 all squared. So what I can do pretty much is I can start rearranging this. Due to my log laws, I can bring this negative 2 down the front here. So this is what I'll have. E to the negative 2. This is still in the squared, by the way. Negative 2 natural log of e all squared. Natural log of e is 1. So we have e negative 2 times negative 2 all squared. So what we have is 4 on e squared. So the coordinate is 1 on e squared and 4 on e squared. That is the coordinate of A. Okay, and that would be the answer. You'd include all that other working, but I write very big, so not enough room, sadly. Okay, so there's another question. Okay, the graph of the function has a point of inflection at this point. Determine P. Okay, righto. So the point of inflection is when f double dash of x is 0. So the second derivative. So we know what the first derivative is. We got given it up here. So let's just write that down. So this is where we'll need to differentiate. 2 natural log of x plus natural log of x all squared. Let's differentiate that. Again, so now f double dash, this term, if I differentiate I don't need to differentiate the constant, just the function here. So I'll have 2 times by 1 on x plus, if I differentiate this term here, I need to use the chain rule. So bring the 2 down the front, so 2 natural log of x times by the derivative of natural log, which is 1 over x. So what we have is f double dash of x is 2 on x plus 2 on x natural log of x. Okay, and now I'm going to rub stuff out because should be right actually. Alright, so point of inflection, set this whole thing equal to 0, and I can take out a factor of 2 on x if I wanted to. So I have 1 plus natural log of x. Okay, so we know then pretty much there's a point of inflection at 0, and there's another point of inflection with this bit here. So what this statement is saying is this multiplied by this must be equal to 0. That means both of them need to be 0, so that means this needs to be 0 or this needs to be 0. So we can get rid of this bit by dividing both sides by 2 on x. So we have 0 is equal to 1 plus natural log of x. Negative 1 is natural log of x. That means x, oh, that's e, sorry. I don't know why I wrote that. That means x is e to the negative 1. And they said there's a point of inflection at e to the x equals e to the p. But we know what that p is, so p is negative 1. Okay? And that would be the answer to this. I'm surprised it's only 2 marks. But anyway. Moving on now to question 14. Alright, so this is a bit of trigonometry. So what will you do is go straight to your formula sheet. So this is the math methods formula sheet you get given. And we're looking for the area of a triangle. Now, if we go straight to a trigonometry section, there it is. So what this means is pretty much if you have a side length of this particular, if you have this angle here A, and you have, not A, if you have B and C, you can work out that area by multiplying these two lengths and finding the sine of this angle and dividing it by half, and that'll give you the area of this triangle pretty much. So, write that formula down, gives you a mark straight away. Area is A, not A. Why do I keep writing A? Yeah, they don't have it in here. But in this case, alright, we'll have to adapt our formula. So, what we have is the angle B is 30 degrees. We have little c is 3 and little a is 6. So area is going to be a half AC sine of B. So write it like that rather than how it's given the formula sheet, because they've labeled the triangle like this. So you need to label your formula how it's labeled in the question. Then you'd pretty much substitute. So a half times by 6 times by 3 sine of 30 degrees. Now, if you want to work out sine of 30 degrees out of a calculator, you'll need a special triangle. So you'll need your 60-30 triangle, root 3, 1 and 2. We're looking for this angle, so opposite on hypotenuse. So sine of 30 degrees is a half. So that means we have a half times a half times 6 times 3 is 18. So that means we have 18 on 4, therefore 9 on 2. Now they said area, so go units squared or whatever they said. Oh, it's meters, so you go 9 over 2 meters squared, okay? Because it's area. Righto, let's move on to the next question. If you have any questions about that one, leave some in the comments and I'll try my best to answer them. Oh, my coffee's going cold. Anyway, alright, solve these equations. So, make x the subject in all these ones. If you ever see a solve, yeah, pretty much. Alright, for this one, divide by 4. So I have e to the x. 100 divided by 4 is 25. So therefore, x is going to be natural log of 25. Okay? Pretty simple. Alright, let's take a look at this one here. So what I'm going to do straight away, before I combine the logs, is bring this 2 up here. So I'll have natural log of 4x squared minus natural log of 4, or not natural log, log base of 4 of x minus 1 equals 1. The reason I can do that now is because I can combine the two logs. So if you have a log minus a log, you divide what's on the inside. So log of 4 of x squared on x minus 1 equals 1. Okay? Now I'm going to convert this to an exponential. That means 4 to the power of 1 is equal to x squared on x minus 1. So that means 4x minus 4 is equal to x squared. So therefore, x squared minus 4x plus 4 equals 0. This happens to be a perfect square. If you think of two numbers that multiply to give 4 and add to give negative 4, you can straight away think of x is minus 2 and x is minus 2. So I can rewrite that as this. So therefore, the only solution to this one is x equals 2. If I square root both sides, undoes the square, and I'll have x minus 2 equals 0. Therefore, x equals 2. And that's my answer, pretty much. If you have any questions about this stuff, leave some in the comments and I'll try my best to answer them. I do have videos on the channel explaining how to solve log equations if you want to go into a bit more detail, but otherwise, that's about it with these ones. Alright, let's take a look at question 16. Alright, so this one's a bit of an interesting math question because you actually don't do much math. Well, that's a lie. It's a different type of math. It's not calculating or solving. It's explaining. Oh gosh, it's explaining. But that's okay. So, consider the graph f of x. Identify the second derivative f double dash of x in the diagrams 1, 2, 3. So, the second derivative could be any of these. So, it's like, we need to look for characteristics that help us. So, straight off the back, the second derivative will have roots at the point of inflection. So I would write that, and I'm not going to write a response because I've got a pen here and it's a bit annoying. So the roots at the point of inflection. So the points of inflection on our graph are about here, 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 here. And if I look at all these, that one doesn't match it. Neither does that one. So the only one, because that matches it there, because it's slightly less than 1, that one is slightly less greater than 2. Doesn't match here and it doesn't match there. So straight off the back, I know it's 1. And now I've pretty much got to prove it's 1. So I would write roots of the point of inflection. And now I want to look at pretty much the nature of the curve. So if we take a look at our function here, the gradient is positive up until this point here. However, we need to analyze the rate of change of the gradient. The gradient is changing negatively. So what I mean by this is it's at its steepest point here, but it's slowly decreasing in steepness until it gets to here. And it's still decreasing until it gets to here. So that means in this region, between like slightly less than 1, like 0.8, and slightly greater than 2, 2.2, the second derivative should be negative. And we can see that's present here. The second, oh, the highlighting's not working. That's a bit rubbish. Anyway, we can see the second derivative is negative here because remember this axis represents the second derivative, f dash. So we can say it's that, and we can say, alright, between here, between like, let's say 2.2 and up until, let's say, what's that, would be 3.8, the second derivative is positive, which makes sense here because this is about 2.2 and this is about 3.8. So I would write that in your response. I'm not going to write a response there, but those two big ideas will justify why the answer is 1. Okay? So talk about the roots of point of inflection and talk about the concavity. Okay? Like done here. So you can know straight away it's 1. Right? If you have any more questions about this one here, just try and leave some in the comments and I'll try my best to answer them. But let's move on to question 17 now. Okay, so the volume of water in a tank is represented by the function of the form V of t is equal to A e to the kt, where V is liters and t is in minutes. Initially, the volume is 100 liters and is decreasing by 50 liters per minute. Determine the time at which the volume is decreasing at a rate of 50 on 7 liters per minute. Express your answer in the form log of A. Holy dooly, that's a mouthful, but that's okay. Let's break this down. So, what I picked up from that was the word initially. Hopefully you picked that up too. So that means t equals 0. So when t equals 0, the volume is 100 liters. Now, what does this bit mean? So look at the units here, liters per minute. If you have liters on minutes, that's pretty much dv dt. So that's the derivative, the steepness at that point. So when t equals 0, dv dt, oh, that's a terrible way to write. So when t equals 0, the volume is 100 liters, and dv dt, now they say it's decreasing, so the way we represent decreasing is a negative sign, so negative 50 liters per minute. Okay? So I got all that information from that little sentence there, okay? Which is going to help us so much later on. So identifying the stuff like that and straight up helps you much later in the question. Now, express the time when the volume is decreasing at a rate of this. So we're looking for the time when dv dt it's decreasing, so negative 50 on 7. And that's my question pretty much. I got all this from 2 sentences, okay? You just got to look carefully for it and look at the wording of it. So you can tell it's a derivative because they've given liters per minute. This is volume, which is in liters per minute. So if you're given a unit where it's liters divided by minute, that means dv dt. Otherwise known like centimeters cubed on seconds or something like that would be another example. But anyway, let's try and work this out. So we don't know anything about our function at the moment, so it's not going to be much help at the moment. So what we're going to do is pretty much put in our initial conditions here. Oh, that highlighting is really annoying. Okay, let's see if I can just highlight this stuff here. So we're going to place this stuff in here. So v of 0 is equal to a e to the k times 0. We know that's 100, so 100 equals a e k times 0 is 0, so e to the 0 is 1, so that means a is 100. There we go. Now we know a little bit about our function here. So 100 e to the kt. Now, we also know this information here, which is going to be helpful. So we're going to differentiate this guy. So dv dt gives me, bring the k down the front, k 100 e to the kt. So when t equals 0, dv dt is negative 50, which is going to help us find our k value because this term will turn into 1. So we'll have negative 50 is equal to k times 100 e to the 0, which is 1. So that means we have negative 50 is equal to 100k. That means k is negative a half. Okay, so hopefully you can see how I got that. If you can't, try and leave something in the comments and I'll try my best to answer it, or I might do a separate video explaining this into further detail. But I have done a pretty good job here, I reckon. But anyway, let's continue. So let's rub some of this stuff out because there's not enough room into the next question. What to get rid of, what to get rid of. Let's get rid of this. So that's raw working. If you want to look at the working, just rewind the video pretty much. V of t is 100 e to the negative 0.5 t. There we go. That's our function. It has all of its, well, unknowns known, except for the variables, but those change with different inputs and stuff. So, what was the question? Determine the time when dv dt is that. So, okay, so differentiate that again. dv dt is negative 50 e to the negative 0.5 t. So what I did there was differentiate that. So I brought the negative a half down the front and gave me negative 50. Now we're looking for a time now. So we're solving for t because we know this bit is going to be here. So we replace that with negative 50 on 7 is equal to negative 50 e to the negative a half t. So I changed it to a fraction because we're going to do some algebra and the decimal is going to annoy me. So we've got to go there. Divide by negative 50. So you have 1 on 7 is equal to, oh, forgot the equal sign. My bad. 1 on 7 is equal to e to the negative a half t. Okay, so apply natural log. So natural log of 1 on 7 is equal to negative a half t. So I have pretty much natural log of 7 to the negative 1 is equal to negative a half t times by negative 2. So I have negative 2 natural log of 7 negative 1 equals t. Negative 2 times negative 1 is natural log of 7 squared, which is t. So the time is natural log of 49. So in this case here, a would be 49, but our time is, when it's at this rate, is natural log of, let's get rid of this, get out of the way. Natural log of 49t, okay, and that's in minutes. So I'll give you some crazy number because you can't work that out in your head. But anyway, right, so I'll take a look at these next questions in the next part of the video because this is already 36 minutes long. So I hope you enjoyed the first part. I'll cover the next couple questions in the second part. Thank you so much for tuning in. If you have any other questions or anything like that, leave something in the comments and I'll try and get back to you, okay? Anyway, see you later.